Hello students, welcome to That's It YouTube channel. I am KASU Sir. Today I am going to discuss one of the most important topic for JEE or NEET preparation from chemical bonding. You could see on your screen, the topic's name is hybridization and shapes. So many students had asked me in the past or asking me continuously that sir, is there a simple method to draw the geometry of a particular molecule or to predict the hybridization or number of lone pairs? Then as per our experience, we determined a formula which would be multitasking. That means by using this formula, you can predict hybridization, geometry, as well as number of lone pairs on the central atom of a given molecule or ion. So it's a very what you call versatile formula or application that we're going to learn today. So I want you to watch until the end of this session, and you know what to do if you like the video, right? Please like, share, and subscribe. So let's start with this session. So first of all, you should know the definition of the hybridization, like you could see on your screen. It says that the valence orbitals of the isolated atom intermix to form the new orbitals. Alright, so orbitals are mixing up with each other so that to form a new orbitals which are having equal energy. So this point arises from a phenomena that if I have, for example, I have what you call methane molecule with me, like I have four hydrogens on what you call the carbon in methane. Now the point arises which hydrogen need to be chlorinated. Suppose I am interested in chlorinating the methane molecule, like you could see when I am doing the chlorination, I would get methyl chloride, isn't it? So the point arises here that which hydrogen would be replaced, isn't it? Like you have the options, you have the northern, southern, eastern, and western hydrogen atom. Now the point arises which hydrogen would be replaced. Now some people say that since this is closer, east will go. Alright, that is not the phenomenon. In order to understand this, you should write the electronic configuration of carbon. What it is? Valence shell only I am writing 2s1 and 2p3. Alright, so you can see that there is one electron here and three odd electrons with the p orbital, which are forming the sigma bond with the hydrogen atom with four hydrogens. So these are all the sigma bond pair of electrons. Therefore, if you take hydrogen atom, you know that it persists s orbital. So you can see that there are four sigma bonds. One is formed due to ss overlap, s orbital of the carbon and s orbital of the hydrogen. One is ss overlap. The three are sp overlap, leading to the formation of four sigma bonds. If that is the case, bond energy of one should be different from the rest of the three. But it was noticed by Linus Pauling, who has got immense contribution to the periodic properties, that it is not the case. All the four carbon hydrogen bonds are having equal bond energy. In order to explain, sir, how come all the carbon hydrogen bonds are equal, the concept of hybridization had been introduced. Over here, what happens is while the hydrogen atom is approaching the carbon, the s orbital and the 3p orbital we mix up with each other, right? The s orbital is mixing up with what? The p orbital to result in a new orbital which is having somewhat shape like this, known as sp3 hybrid orbitals. Can you hear me? New orbitals. So this is what the concept is called hybridization. So you can see 1s and 3p will mix up to give you 4 sp3 orbitals. So the new orbitals which are formed here are called hybrid orbitals, labeled as sp3 because 1s and 3p are combined. Alright. So how do you accommodate the 4 orbital around the central atom? What's the best possible way? Like you could see that the best possible way would be like tetrahedral, isn't it, right? The best possible way is tetrahedral. Each is carrying one odd electron. Now there are 4 sp3 orbitals which are overlapping with the hydrogens. These are the hydrogens s orbitals. To give you all uniform bonds or identical bonds is nothing but sp3 of the carbon and s of the hydrogen atom. Hope you understood, isn't it? So methane has, you would say simply 4 sp3 s sigma bond. All the 4 are same. Therefore, all these bonds will have the equal bond energy. So this is we explain the concept called as hybridization, right? The purpose of hybridization is to give the molecule symmetry and thus stability. So intermixing of the atomic orbitals of approximately same energy to give rise to the equal number of, for example, 4 are mixing, you will get 4 equal number of equal energetic orbitals. What I mean to say, like if 1s is mixing with 3p, you have got what? 4 orbitals total sp3. Then geometry will be tetrahedral, so that the angle is what you call maximum. 1 is mixing with 2p. This leads to 3sp2. Geometry is planar, triangular planar or trigonal planar. Next, 1 is mixing with 1p. 1 plus 1 is 2. sp. Geometry is linear. There are cases where n minus 1d orbitals are also involved. In that cases, n minus 1d, one such orbital and 1s and 2p gives rise to 4 dsp2 orbital. This you will see in complexes usually, and this is coplanar in geometry. Alright. There could be n d orbital also, like 1s, 3p, 1d is 5, sp3d, trigonal, bipyramidal. You have 1s, 3p and 2d, 6, sp3d2, octahedral. So likewise for every shape, you have a different hybridization, right? So after knowing this table, now it's our turn to move on to the next topic to understand. You see, this is very, very important, right? Unless you understand this, how the hybridization takes place, etc., you're not going to understand the next phenomena. You can see how it is happening. I want you to go through the diagram so that you can understand things better. I just explained here with the help of this orbital orientation. You can see S and P are mixing up to give you sp, hybridized orbital. So 1 plus 1 is 2, one sp is aligned like this, the other sp is aligned like this. Alright, so when they are forming a linear bond, you can see the angle between that is 190. So that's what happens in alkyne, right? So in alkyne, the carbon atom has sp hybridization and bond angle is expected to be how much? 180 degree. Likewise, you can explain the formation of all the other hybrid orbitals. Hope you understood, isn't it? Okay. Hope you understood. Hope you are following, right? It's a very easy phenomenon. Now, let's move on to the shortcut. Alright. So that shortcut or the concept related to the hybridization is like finding out hybridization, geometry, number of lone pair by using a very simple formula. This is the formula which you can see on your screen. Hope you can see it on your screen. Is to find the hybridization shape of a molecule, find the S. S is not sulfur here. S is just a random number of the central atom. You can see here what does S denote. S actually denotes the number of lone pairs and bond pairs summation. Number of bond pairs summation or number of atoms attached to the central atom. So this is the sum of lone pairs and bond pair. Now the formula goes like this. You can see number of valence electrons, alright, plus hydrogens and halogens attached to the central atom. You have to see how many hydrogens or halogens attached. Minus if there is any charge on it. If it is a molecular ion, you must write minus of that charge. Minus of minus charge will become plus. Minus of plus charge will become minus divided by 2. 2 is because we are finding out the pair. Alright. So please take a screenshot of the formula. This will help you. Okay. You can see it on your screen. I want you to make a note of that formula. Alright, I think you can see it on your screen. I'll move a bit so that you can take the screenshot if you want. Okay, chalo. So after ascertaining how many bond pairs and lone pairs are present in the given compound, it's our duty to know tentatively the table pertaining to the n by 2 value and number of atoms attached to the central atom. This table will give you the complete idea regarding the geometry of every molecule, believe me. See how it goes. Suppose, listen now, I'm going to give you some assignments also on this. I'm going to explain you the example. Like if the n by 2 is 2, atoms attached are 2, then when you subtract this s from the atoms attached, you will be getting lone pairs. And based on this value, hybridization can be predicted. 2 means 1 plus 1, sp. Geometry for sp is linear. Examples are these, and bond angle here I have mentioned, right? You can take CO2 and BeCl2. I'll take the example of BeCl2. Alright. You have to find the S of central atom. Central atom is the one which has more covalency or which has more oxidation number. You know, beryllium has 2 oxidation number, chlorine has 1 oxidation number. So beryllium is the central atom. Valence electrons plus number of hydrogens attached to the central atom 0 plus number of halogens, that is chlorine, attached to the central atom are 2 minus, is there any charge? No, by 2. So S value is turning out to be 2. This is what I mentioned. After that, what you have to do is subtract the number of atoms attached from it. How many atoms are attached to the central atom? This gives rise to the lone pair. So if S value is 2, that means hybridization is SP, geometry is linear. You can see it on your screen, isn't it? Alright, very easy, isn't it? Okay. Now you can take some more example like 3, 3, 0. This you subtract, you will get this. Subtract, you will get this lone pairs. And based on the n by 2 or x or s value, you will be getting the hybridization. For example, say I have SO3 minus 2. I want to work out on SO3 minus 2. I'll take SO3 minus 2 here. I'll find out the S of S. S is the central atom. Valence electrons, you know, it's 6th group element. Plus hydrogen 0, halogen 0. Minus of charge is minus 2, you can see, by 2. So this is turning out to be 4. 4 means how much? Valence electrons. Alright, SO3 minus 2 is turning out to be valence electrons 6 plus 2 by 2. It should be like S value should be 4 actually, right? 6 plus 2 by 2. So that means the hybridization is sp3. You strike off this from here. So it should be sp3, okay, minus number of atoms that are attached to it are 3. That means there is one lone pair present on it. So geometry, as per the geometry, it should be tetrahedral. You can see that sulfur having one lone pair and 3 bond pairs. Alright. One has a double bond, the rest of the 2 has negative charges. So this geometry is called pyramidal, triangular pyramidal shape. So likewise you're going to work out, right? So the examples here have been shown. I want you to go through these examples and try to understand how these examples can be worked out. Like another table, you can see 4, 3, actually that SO3 minus 2 should have been kept here. SO3 minus 2 should have been kept here. Alright, it belongs to this example category. Alright, you can take any example like that. It's not this. Okay. Now we will take some more. I'll show you some more example here. So, for example, you have, let's say, any other example that we would like to take is what else? H2O, very popular example, right? Oxygen is the central atom. Valence electrons plus hydrogens attached are 2, halogens attached are 0, minus charge is not there. So you got 8 by 2. Hybridization is how much? How much is what? Hybridization is sp3. Minus number of atoms attached to the central atom are only 2. That means there are 2 lone pairs. So as per hybridization, we need to draw it, right? So oxygen is the central atom. And you can see there are 2 lone pairs and 2 bond pairs. So if you draw like this, it will be bent in shape, V shape or angular, isn't it? Okay. So let's work out some more examples, little complex ones. Okay. So Next n by 2 5 wala example we will see, like which one, yeah, ClF3. Let me pick ClF3 here. Chlorine is the central atom. It has got more covalency. It is associated with 3 fluorines. So S value of chlorine, valence electrons plus halogens attached. Attached only you should count, not the total. There is no hydrogen, no charge, by 2. 5 means sp3 dehybridization. So for sp3d, number of atoms attached over here are 3. That means there are 2 lone pairs. For sp3d, you must draw actually trigonal bipyramidal. And remember, in all trigonal bipyramidal structures, the lone pair must be accommodated at equatorial position. You can see that these are called equatorial positions. There are 3 equatorial positions. These positions are called equatorial. These 2 are called axial positions. So always keep the lone pair in trigonal bipyramidal structure on the equatorial position, right? So over here you have to keep 2 lone pairs, and there are 3 fluorines. So this structure is clearly called as T shape. Hope you understood, right? So likewise, you have to keep what you call drawing when the S value is known. So you can predict the lone pairs, you can predict the hybridization and everything, right? You can see 6 and 6 examples are also given here. 6 and 4 examples are also given. Like if you want to work out 6 and 4, you can work that out also, like XeF4. XeF4 valence electrons of the xenon are 8 plus 4 halogens attached, no hydrogen, no charge. 6 means hybridization sp3d, minus 4 atoms attached to lone pairs are present. So sp3d means octahedral you need to draw, and there are 2 lone pairs. You can keep it wherever you want. All the positions are identical. So this geometry is called square planar. So likewise, you have to draw the structure of all the examples which I have mentioned here. You please practice. When you practice, then it will be easier for you to work out, right? So for example, randomly I gave you a set of 3 different compounds in 4 different options. You can call this as option A. Alright. Now you need to predict that every member of that particular option has sp3. Alright, to do that, valence electrons of the central atom plus hydrogens attached, halogens attached 0, minus of minus 1 plus 1 by 2 over here. Alright, same thing, no? 7 plus halogens attached are there 4, minus of minus plus 1 by 2. Here 7 plus halogens attached are 4, minus of plus by 2. So you can see here these values are turning out to be 7, 8 by 2, that is nothing but 4. 4 means sp3. 7 plus 5 by 2, that is 12 by 2. 6 means this is sp3 d2. This is 7 plus 4, 11 minus 1, that is 10 by 2, that is sp3d. So options are not matching, isn't it? Alright. Next, xenon has 8 valence electrons, isn't it? Plus number of halogen 0, hydrogen 0, charge 0, directly 8 by 2, 4. Over here, 8 valence electrons plus no hydrogen, no halogen, no charge by 2, that is 8 by 2, 4. Over here, 8 plus 4 halogens attached by 2, that means 6. So this is only sp3 d2, remaining 2 are sp3. So let's move on to the next example. Valence electrons plus hydrogen 0, halogen 0, minus of minus 2 plus 2 by 2. So this is turning out to be 4. Valence electrons, hydrogen 0, halogen 0, minus of minus plus 2 by 2. This is also turning out to be 4. Valence electrons plus hydrogen plus halogen 0, minus of minus 2, that is 6 plus 2 by 2. This is also turning out to be 4. That means in all the cases the hybridization is sp3. Over here you work out 5 valence electrons of the phosphorus plus 4 halogens attached, minus of 4 all charge by 2. Next, boron 3 valence electrons plus 4 halogens attached, minus of minus 1, that is plus 1 by 2. Over here anyways we I think have predicted this as sp3d2 already. So this is 8 by 2 sp3 and this is also 8 by 2 sp3. So this is not matching. So you can see in option C, all the compounds are having sp3 hybridization, and you know how to predict the geometry once if the hybridization is known to you. Alright, so this is very easy. For example, lone pairs are asked. Then in that case, what you will do? Over here, for example, in option A, you got the x value or s value as 4, minus 4 is 0 lone pairs. Here you got this value as 6, minus 4 atoms attached means 2 lone pairs. Over here you got this value as 5, minus 4, that is equal to 1 lone pair. So you can find the lone pairs as well once the questions are asked like this. Hope you understood the session, and keep watching. The sessions which are useful for you are available in our channel. You go to the playlist, learn any topic that you are not very sure of, and if you have any doubt related to any topic, or if you want me to explain any topic, please post it in the comment so that I can address. Until then, please take care of yourself. That's it.